Right, hi everyone and welcome to IV Tutor. We are looking at the model view architecture or model view programming topic today with regard to exam preparation. And this is no doubt one of the most difficult topics to understand, or maybe the longest in terms of concept and everything going on within this topic. So we'll try and break it down and understand the basics and the foundation of model view programming and how you can prepare for questions under this topic in the exam. So the first thing to understand is that the model view architecture stems from the MVC pattern, and the MVC pattern simply stands for the model, the view, and the controller. So it's MVC, model view controller. And the model is used to represent your data. The view is obviously for presentation, and your controller is what sits between your model and your view. In other words, it controls the activity that is happening between the model and the view. So in other words, it's controlling the data flow from the model to the view, and data changes that are happening from the view and updating the model based on that. So in other words, it's controlling the flow of data between the model and the view. That's the controller. So the MVC pattern is more like a very traditional pattern. And from there, we then go to the model view architecture. So you end up with the model view by combining the view and the controller. So from MVC, if we combine the V and the C, then we end up with the MV, and this simply becomes your V. So that is how we end up with the model view architecture. And there is two separation between your data and your presentation, because that is very important to separate your data handling from how it's presented. And this combination provides a simpler framework. In other words, there are less moving parts when compared to the MVC, but not really less, as you will see when we move forward, because instead of a controller, we've got something else in the MV pattern, but it's still sitting more on the side of the view, right? So that is basically how you move from the MVC pattern and you end up with the MV pattern. Now, I think for most students, it's difficult to fully understand what are we talking about whenever we talk about the MV architecture. What is really going on? And especially if you didn't do assignments on MV and you didn't get to write the code to get this to work, it becomes difficult to have that mental picture in terms of when does it apply? When do we use it? Are we talking about widgets, windows? What's going on with the MV architecture? When you talk about a view and model, because there is a general concept of a model and a view that we know generally in terms of all presentation classes like your widgets being classified as views, and then all data classes then being classified as your models, like in general. This is not what we are referring to here when we talk about models and views. This is a very specific thing that we are talking about. So let's say you want to build a user interface like the one that we see, right? And we can identify that, okay, we've got our widgets sitting here, our line edits, spin boxes, labels, push buttons, and everything. And with this user interface, you can sort of make sense of what's going on here. We are going to type in the a journal information here, like the author, the year, title, and everything else. And if we click the add button, we want to see this information being presented here. In other words, we can say this here is a table, right? So it's then presented on this table. And if we want to remove a record, we can click on the record and then we click remove and it's gone. Or we can also maybe type in the author, or then we put in our selection criteria and then we click find and then we see our results here. But basically we've got a table here. Now, how do you end up with something like this? What would you use here? This is where the model view architecture then comes into play. The kind of view that you use here, the kind of widget that you use here is what we are talking about under the model view architecture. So if you open a Qt Creator or Qt Designer and you want to build this user interface, you're going to go in this section. You're going to see two sections for what you could possibly use here for your table. The first section says model based, and that is what we're going to be talking about. And the second section says item based or item widgets, which is what we also talk about right at the end. So when we talk about the model view architecture, we are actually here. We are talking about these guys. And our main focus is basically going to be on three main views or three main types, which is your list, your tree, and your table. We will not talk about column views or any of this. So for the purposes of our studies, we'll only focus on three kind of views, which is your list, your tree, and your table. So obviously from here, what we are seeing here is our table that is this guy. I'm going to put two ticks there. This is what you would then drag, drop here, and you've got, and this is a Q table view. So this is where the basis of the model view architecture comes from. Like, how do you end up with a user interface that looks like this? So this is your view. So if we look at this diagram, we can say that you are going to type in something, you click the add button, then this information is going to display on the table, right? But because this is just a view, where is it storing that information? What if the user double clicks something on the view to edit it? And then it stays like that. What's really happening? So that is the model view architecture that we need to discuss today and understand what's really going on. What are the classes involved in the model view architecture? So before we go into more details, right, I want to say this table that you put here is what we're referring to as the view, right? Behind this table, there is what's called a model that is sitting somewhere, right? So what's actually going on is you type in something here. When you click add, this data is not going to be put on the view. It's actually going to the model. And once the model has been updated, the view is then pulling those changes and displaying them on this table, right? That is how everything is actually working behind the scenes. And we need to understand what is involved, what classes are involved under models, what classes are involved under views, right? And we've already seen from here that we've got three types of classes that we're going to be discussing: list views, tree views, or list view, tree view, and table view. And the actual class for a table view, for instance, is actually called Q table view. So we need to understand how this works together, but it was very important to clarify what are we referring to when we talk about the model view architecture, right? So we are talking about the views or the widgets that you can put here to use them to display your data. And we are saying that these views work with what is called a model that is handling the actual data side of things, and hence model and view. So when we say view, we're not referring to this window here as the view. No, we're referring to this part as the view. What about the model? Now, we can go into that, right? So the first thing to understand is how everything works together. There are three main components involved. You've got the model, you've got the view, and you have a delegate, right? And we're going to talk about the delegate a little bit more as we move forward, but it's important to understand the three main players, which is in the MVC, you've got the model, the view, and the controller. In the MV, you've got the model and the view. And though the delegate does not make part of the name, it's actually one of the most important things. So your model is what is used to provide interface to the data. In other words, your model does not need to store the data. It simply allows your view to pull the data from wherever it's being stored, right? So a model provides an interface to the data. So the data here could be a table, it could be a tree, it could be a text file, it doesn't matter. But because of the interface provided by the model, when it gets here, it's displayed as a table if we are using a Q table view, and an equivalent model, right? So the model is used to represent your data, or it's used to provide an interface for your data to the view. The view is obviously used for presentation, right? It's used to display the data. And when we talk about the view, we're talking about this guy, to display the actual data. That is what your view does. And then your delegate sits between your model and your view, and it's used for rendering items on the view. In other words, your delegate can be used to control how these items are displayed on the view. An example is, instead of displaying a number, you want to display a star rating. So you can have a number that is between 1 to 5, but you don't want to show a number 1, 2, 3, 4, or 5. You want to show those numbers as stars, like as stars. So you can be 1 star, 2 stars, 3 stars, or 5 stars if it's representing a rating. So those things can be controlled by a delegate. And at the same time, you can use your delegate for editing purposes. We'll talk more about delegates as we move forward. But this picture gives you a summary of how these classes work together. So we've got models, we've got views, and we've got a delegate. We're going to need to understand what classes make up a model. If we talk about a model, what classes are involved? If we talk about a view, what classes are involved? We now know it's only 3 of them. And if we talk about a delegate, what classes are involved? But when we talk about classes, mostly we are talking about models and views. That is where you really have to remember which classes can be used for models or for views, right? Now, moving forward, the model and the view and the delegate are always communicating. The communication that happens between these 3 things happens automatically, right? So the model is communicating with the data source, right? And the delegate is sitting between the model and the view. In other words, a delegate can be given the role of a controller. You can see a delegate as a controller. We're going to talk about comparing the MVC to the MV architecture. And one of the key things in doing that comparison is how your delegate can be seen as a controller, right? And I think that is all we need to talk about. So now let's talk about the communication that happens between your model, your view, and your delegate. And I said it's automatic, which means the most crucial thing to understand is, if you look here, I said the moment you click the add button, immediately it shows here. But behind the scenes, this data is not just being taken from here and being put on the view. No, this data is being taken here and being put in the model that is backing this view. But the moment this data makes it to the model, automatically it's displayed on the view, which means you don't have to do anything to tell the view to pull the data whenever this changes. They are always in sync. Every single time your model changes, your view automatically updates. Every single time you go on the view, double click something, you type in your edit, you press enter, the model is automatically updated. So that communication that is happening between your model and your view happens automatically. And this is achieved using signals and slots. So signals from the model will tell the view about, well, hey, there's a change, right? So every time there's a change in the model, a signal is emitted in order to tell the view that something has changed. And at the same time, or in the same manner, if something changes on the view, the model needs to know. So the model is always emitting signals whenever there are data changes. The view is also always emitting signals wherever there are user interactions happening on the view, like selecting rows or updating information on the view. And signals from the delegate are also used during editing to tell the model about data changes and to tell the view about the state of the editor, because we said the delegate is used for rendering items for editing. We'll talk more about what do we mean when we say it's used for rendering items for editing a little bit later. But these 3 objects are always in sync. They are always communicating. And this automatic response to events happening in the other objects can be seen or viewed as an implementation of the observer pattern, because you remember with the observer pattern, it means you've got an observer and you've got a subject. And whenever something changes in the subject, your observer automatically responds to those changes happening in the subject. So it can be seen as an implementation of the observer design pattern. And you see, once we go through exam paper questions, that it's very common to get a question that says, can you compare, or how is the MV architecture an implementation of the observer design pattern? And all you have to explain is that, well, the model, view, and delegate are always responding to each other automatically. And that alone can be seen as the observer design pattern. Now, when it comes to models, it is very important to understand models as classes. And every single class under models inherits from the Q abstract item model. So in other words, this is the topmost class in the hierarchy. So we are going to have different classes that can be used as models, depending on what you're trying to achieve. But the topmost class that every model inherits from is the Q abstract item model class. In other words, it provides the interface for views and delegates to access data, right? And you will talk about model indexes a little bit later, but depending on the model that you are using during your semester, you may learn more about the functions that are defined in a model class, right? So that depends on which one you really get to use during your assignments. But basically, if we talk about model classes, these are all the classes you can deal with. And these are actually not all of them. There's a few that are not in this diagram. But when we talk about data handling, these are the model classes you need to be aware of. And every single semester, it depends on the assignment. They can give you questions based on this or that, or this or this or that, right? So it's very important once, as part of exam preparation, to then understand which model you used during assignments, because you may have to understand how to use that model. But regardless of the model that you used during assignments, you have to understand all models in terms of when would I use which model. Now, there are two aspects to models that I want you guys to understand. Number one, the kind of data that it's meant for, right? And number two, the type of model. Is it abstract or is it concrete, right? Abstract or concrete. This is very crucial, especially when you start comparing these models. So, and what I love about these models is the names tell you whether it's abstract or not. So the Q abstract list model is used for list data. Q abstract table model is used for tabular data. Q string list model, this one now is a concrete model. And the same goes with the SQL relational table model and the Q standard item model. So you have to understand which ones are abstract and which ones are concrete. And at the same time, understand which kind of data do I need to use with which model. So if you're dealing with tabular data, you want to go with a Q abstract table model. If you're dealing with list data, you want to go with a Q abstract list model or Q string list model. If you're dealing with hierarchical data or tabular data even, you can go with a Q standard item model. So it can be used for hierarchical or for tabular data, right? So when you talk about hierarchical data, that's your tree. If you want a tree view, otherwise, we've got other models that are not sitting in this diagram, like a Q file system model. It's not here, and that you can also use as for a tree. But basically, these are the basic classes that you need to understand when we talk about models, right? And you must be able to differentiate these classes in terms of the type of data it's meant for and whether it's concrete or abstract. Now, one of the common questions that you get when it comes to choosing a model is, would you go with a concrete model or would you go with an abstract model, right? And sometimes the questions you get here would be something like, you are a developer and you've been given a choice to choose between the Q standard item model or the Q abstract table model. Which one would you choose, right? And there is no wrong choice. It just depends on the context. What are you going to use it for? So for that kind of a question, I don't think there is an absolute correct answer like, oh, you must always choose the Q abstract table model, or you must always choose the Q standard item model. The question is, can you justify your choice? Because using a concrete model like the Q standard item model makes it easier to build your application because it's a concrete model. It has been implemented already, which means you don't have to inherit from an abstract class and implementing your own model, because implementing a model is a bit of an effort. So one advantage could be, look, if I'm dealing with a small data set, I can just go with a Q standard item model because it's easy. It's implemented already. It's ready to use. So why not use it? But it also comes with its disadvantages, especially if you are dealing with very large data sets. And the biggest issue there is performance issues. You have to, because the Q standard item model only deals with Q standard item objects, right? If you are dealing with your application that is using, let's say Q actions, you cannot put Q actions in a Q standard item model. You have to copy that data and then create an instance of a Q standard item so that you can put that data in the model, which is duplication. So it can result in data duplication when you have to cast between your data objects and Q standard items. So if your application is about managing students or a library of books and you want to use a Q standard item model, you are going to need to copy information between the Q standard item and your objects, which results in data duplication. And also there's a bit of overhead when instantiating the model, setting up the headers and creating the model. And the disadvantage is it doesn't persist data because it can be treated as an item-based model. When I say item-based, it stores the data. The data is sitting in the model, which means it's less flexible and it can result in information that is sitting in your model going out of sync with information that is being stored in your memory or somewhere else. So it does have its disadvantages, especially when it comes to performance issues or it can have a memory impact when you start dealing with very large data sets. So that is the disadvantage of using a Q standard item model. So you would want to choose that if you are dealing with a very small data set, and then you can say, look, it's a small data set, the performance or memory impact is minimal, so why not use it? But if you're dealing, let's say, with a larger data set, then you may want to implement your own model by inheriting from an abstract model, because then you can implement your own data structures and control how much data you store depending on your data structures. When we talk about sparse data structures, we are saying you're dealing with data structures where maybe for an object, 80% of the values are blank, there's nothing, right? And you still want to be able to store that data effectively. So by inheriting from Q abstract type of model, you can implement a model the way you want. You can implement features like lazy fetch, where your model does not really fetch the data up until the time it's actually required. That is where we talk about lazy fetching, because you delay the execution of certain things until a point in time they are required. So examples of such models would be the Q SQL table model or the Q file system model, which I mentioned before and said it's not part of this diagram that we were looking at here, but it's also another model that we find in the Qt framework. So that would be, so depending on your requirements, if you're dealing with a larger data set, if you want to implement your own features, then you can inherit from the Q abstract or from an abstract model and then implement it on your own. But obviously the disadvantage there is the amount of effort you have to obviously spend time implementing the model, which can make it a little bit more complicated when compared with dealing with an abstract, with a concrete model like the Q standard item model. So that is one thing I want you guys to always remember, because I've seen questions about that. Now, another thing that you always come across when you start using a model is a model index. And a model index is basically a unique identifier for everything that is sitting in your model. So if we go back to our initial diagram where we talked about a table, right? And we said you could end up with let's say you end up with some data in here. So you've got some rows and columns here. Just for the sake of illustration, let's say you've got 2 rows there with some data in here. A model index is used to uniquely identify each item that is sitting in this model. So you have, I'm not going to put any information that makes sense here. I'm just going to go with, there is information, right? There is data in here. So how do we know or uniquely identify these items, right? And what I mean is, what if the user wants to go and edit the volume number of this journal? So they want to edit this one cell here, right? So when they make this edit, remember this change has to be persisted to the model and then redisplayed again back here on the view. It's a round trip. So remember, something changes on your view, right? That change goes to the model. And when that change happens in the model says something has changed, your view redisplays that value. So when you do it, it doesn't feel like a lot has happened, but actually it's a round trip, taking that value from the view, sending it to the model, and redisplaying it on the view. So how do we keep track of these items? And that is where your Q model index comes into play. So a Q model index is used to uniquely identify these things. And it's not even complicated. It's actually made of just raw numbers and column numbers. So a Q model index, we have the raw number and the column number. And that is how you uniquely identify these things, rows and columns. And that information is contained in a Q model index. So whenever you are passing data around, whenever your model and your view are communicating, or the delegate also involved there, they are using model indexes. And this is clearer if we are implementing our own model, because all functions that we deal with at some point take a model index. Because let's say we are implementing a function that we need to use to set the value in a model. We need to know, where are we setting the value? In other words, we need to receive the model index. And the model index simply has raw numbers and column numbers, so that you can uniquely identify each item inside your model. So that is where model indexes come into play. Now, when we talk about views are used for displaying your data, right? Views are used for displaying your data. And there are three types of views that we are concerned about for the sake of our studies. And these are your Q list view, your Q table view, and your Q tree view. And all views inherit from the Q abstract item view. Now, the good news about views is we don't have to do anything. We never have to implement a view, because all of them are concrete classes. You just need to learn how to use the views. And those are the things we do during when we start explaining how to use a particular model. Or let's say we are talking about how to use a Q string list model. We'll explain how to link your Q list view to your Q list, to your Q string list model. But this video isn't about the actual implementation details. It's just to give you that full picture about the model view architecture, like how does it work? How does everything work together? And your views are obviously those widgets that you see on your form. So you drag and drop, and if it's a list view, if it's a tree, it can look like this. If it's a table, it can look like this. If it's a tree, if it's a list, it can look like this. So these are just examples of how your view would look like, which is exactly this example that I gave you here. This is a good example of a table view. So basically, this summarizes your models and your views. Now, the last item we need to talk about is delegates, right? And depending on what you are doing, you can actually implement your own delegate, and you can use them for styling, like the example I gave you earlier on, where instead of displaying a number between 1 and 5, you actually display that as a star rating. You can do that using delegates. Now, delegates can be used to play the role of a controller in the MVC framework, right? Because remember, they are sitting between the model and the view. So you can use delegates to control how you want your items to be displayed. And you can also use your delegates to render items for editing. What do I mean when I say to render items for editing, which is your fourth point here? What that means is, if you go back, let's say if we look at this table here, and the user wants to edit the author, and they double click here, what's going to happen when they double click is this cell then changes into a line edit, and you can actually type here. So you can actually, you can see your cursor blinking there, and you can just type your new value, and you press enter, and it's updated. So it's the responsibility of the delegate to give you that line edit that you need here so that you can type. Or maybe if it's a number, it can give you a spin box here. So when you double click to edit, your delegate would then render a spin box for you here. And this cell becomes editable. So then you can see there's a spin box sitting here and your numbers are here. And you can then edit the number. And when you press enter, it changes back into your normal cell. So that rendering that's happening where we replace the cell contents with an actual spin box with the current value, and you can edit. That is the rendering that is being done by your delegate. So it is the responsibility of your delegate to render those items for editing. And once that editing has happened, it then emits a signal, and that value can then be persisted into the model. So that is the responsibility of delegates. So we can see that delegates are sitting between the model and the view, controlling the flow of data between the model and the view. They are rendering items for editing. They are controlling how items are displayed. They are also being used to update the model whenever a value changes on the view. So in other words, delegate can then be seen as playing the roles of a controller in the MVC framework. And it's very important, especially when you start comparing the MVC pattern to the MV architecture. And that is actually one of the most popular questions that you get during exams. Now, when we started, we talked about two options when you're building your user interface. I said you can drag your item from here, or you can drag it from here. Eventually, it will look the same, but the way it works is not the same. Item widgets sort of combine the functionality of the model and the view into one item. So you can right-click. For instance, if you drag a table view, which is model-based, on here, you cannot right-click and say, I want to put 5 headers, because the view does not know about headers. All that information is controlled by the model. So all these headers that you see here, this information is coming from the model. The view simply displays. That's all. It doesn't know anything. So you cannot right-click a Q table view and do something. But if this is a Q table widget, now there's Q table view and there is Q table widget. If this is a Q table widget, you can actually right-click and say, I want 5 headers, and then type in your headers, because this widget here is the same component controlling the data as well. It's one thing. They are not two things. So that is the reason why they are then referred to as convenience classes. If you're doing something small and something quick, you can just drag a Q table widget, put it there. You don't have to worry about wiring it with a model and all of that, because it's simple to use. It combines the functionality of the model and the view into one item, and your widget stores the data. So this again is an item-based approach, because your widget is controlling the storage of the data. The only challenge is that it's less flexible, because you cannot separate your model and your view. It's one thing. So you cannot have one source of data and you display it 3-4 different times in different places, because it's one thing. So it's very less flexible. You cannot have multiple views. So it's always preferred to use a model-based framework versus a widget item classes, because of how less flexible they are. They are not good for very large data sets because of that less flexibility that they have. So basically, this summarizes the model view architecture, and I do encourage you to go and read more in the textbook. You can go and read about the MV architecture from there, which is your recommended textbook. You can also go on the Qt framework and just go model view programming and go on the official Qt documentation. They've got a very good document there that illustrates how everything works, how model indexes are implemented, how they work, and the whole interface that a model provides to the view, how all of that works. So for extended reading, I would encourage you to actually go and check out the model view topic in the recommended textbook, which is by Azust, or you can also go and you can also go and read the official documentation on model view programming. That will also help you.